Hey everyone. So today we'll be discussing we'll be working with JSON file using the PySpark. This was the agenda and this was the schedule. This is a recorded session because when I took the live session for some due to technical issues, my recording did not save, so I'm re-recording this. So okay, let's get started. So much before that, I just wanted to let you know that I really wanted to do this in databricks of Azure subscription, but when I looked into the free trial, it had already been expired, so I could not use the Azure portal to create Azure databricks. But never mind, we have community edition, and I'll showcase everything exactly the same in the community edition. So let's get started. First, um, Spark actually can be written in four languages. Initially, um, when Hadoop came into an existence, that is in 2006, but then it became boom in when they released to Hadoop 2.0 version. You could actually write in four different languages, that is Java, R, and Scala and Python. uh, you should note that the Java and R are actually not so famous right now, but pretty much everybody uses Scala and Python. um, Also, you should note that Spark was the developers of the Spark actually created the Spark application, built the application using Scala language itself, which is a functional programming, and Python is being a scripting language. So when Hadoop was actually a boom in 2013, actually it came in 2006, but there was so many improvements during those times. They were used to write in Java code. So they have to write, classes. They have to invoke a constructor, and the code was too lengthy, and it was difficult to understand and difficult to provide the knowledge if some of the team members, gets changed, or maybe they are leaving the organization when there's a new candidate or maybe resource joining. It was difficult for making them understand because it's so huge, even for a uh, small process, for small maybe application or maybe transformation. Java code used to take a hell lot of time, as well as the code that we used to write, it was too lengthy. Nowadays nobody, I mean, not much, very few legacy. You can consider Java, using Java for using Java language to build Spark application is kind of a legacy system now. But yeah, more or less these are very much is still in the is still production usage. They are still using in the production. So basically, we don't use R right now for data engineering because data science people use it. R is for for machine learning and artificial intelligence. Databricks also gives both of these, it's not to worry. So there is a one small misconception that I really want to clear off. The people say that Scala is 10x faster than Python, which is, yes, that is true, but that's not exactly true when it comes to a Spark. See, Scala is a functional programming and Python is a scripting, and moreover, if you are using Scala for competitive programming, or if you're doing some sort of coding that is specifically like, you're implementing some algorithm, doing some if else statement, or pretty much core programming stuffs like, oops concepts or inheritance, polymorphism, whatever those things are, reading a file, writing a file, these kind of stuffs, building an algorithm, searching, sorting, whatever thing. In those cases, yes, agree that Scala is really faster than Python. The execution is very much faster. But when it comes to Scala Spark, if you are using Spark by using Scala language, or if you are using Spark by using Python, both have the same efficiency. Okay, there is not much difference when you are using PySpark or if you are using Scala Spark. So they both yield the same result with the same almost the same efficiency, I mean execution time. But in the production, people use PySpark. That is because Python is very famous, and everybody you I mean at one point they will go through, or maybe they will learn Python, because that is every other person loves to code in the Python, because it is very famous and it's very much used in most of the in a larger community, like Python can be used in web developing, Python can be used in competitive programming, the Python can be used in data science, Python can be used in data engineering. So there is a vast field, so that is why Python is, the audience is large, and there is a large community. The community is very supportive, because the Python community keeps developing new and new libraries, and they have a huge vast library support. For data frame we have, there's pandas library for for having a data frame, and you can also have a data frame in the PySpark. There is list, that is inbuilt list, which is in Python. There is a list, the handling of the list is not so good and so fast and efficient in Python, so that's why they have a separate library for handling, for using lists and stuffs. So that's why Python is preferred. Let's say that you want to connect to some NoSQL DB, or maybe some relational, or maybe like Oracle DB. You can just use JDBC connectivity, or JDBC and ODBC adapters, import those libraries, download those, and use them with the Python, and you can connect to Oracle DB or something like that. So that is how flexible Python is. That is why everybody's favorite is Python, and production also, everybody uses in production also. The PySpark, it's just my opinion, I'm not sure, it's argumentative. Everybody depends on one's own opinion. For me, even I was a kind of a person who I used to say that Scala Spark is really good, but when I started using PySpark, I did not see any difference in the performance. It pretty much took the same time, and when I wanted to explore more, it was more flexible with Python, because I wanted to import some data using MongoDB, and I really wanted to import from RDBMS, that is SQL Server, and wanted to do the join, and I wanted to do something like this kind of fancy stuff. If you want to do it's really good in Python. So that's why many libraries are supported, are available. Let's say that you want to work with JSON, it's there, import JSON. If you want to work with regex operations, there is RE, something like that. If you want to build some the plots, if you want to plot some graphs or something, charts, there is matplotlib, and there's also Seaborn, and there are many other things. So if you want to work with PyMongo, then you can connect to the MongoDB server and import the data, something like that. So that is the reason why PySpark is helpful. So the whole agenda of why I'm telling all these things is because we'll be working with PySpark today. Okay, so and you should know why we are using PySpark, and you should know why we are using JSON, and we'll talk about why we are using JSON in maybe a couple of time now, and in some time. But yeah, let's clear off the why we are using PySpark, and why are we using Databricks, and why are we using JSON. That's the whole thing, right? If I'm going to tell that I'm going to use PySpark and JSON data, okay, that's fine, but why is he using that? Why am I using that? So yeah, this is the reason why I'm, like I was explaining. So we cleared off why we're using PySpark, but then let's talk about why I'm going to show the things in Databricks, right? So you could write Spark programs and applications in Eclipse, PyCharm, and there are many other IDEA, IntelliJ, and there are many more you can write in any ways. These are IDEs, in interactive development environment or something like that. I'm not sure if that's the exact abbreviation for it. So, but these, you could write these, and even you could write, you could write Java also in Eclipse, Eclipse, and you can write in Python or Scala also in PyCharm, and the same goes for IntelliJ. But you need to download, this is a huge file, and all the things, you need to maintain the version, all these things, and you need to provide the cluster, attach a cluster to it, so it's a pain. So there were companies which overcome this. So everybody might have worked in Jupyter notebook, and everybody loves working, that is very easy. Each command can be executed in cells, so that's why there is something like Zplane notebook, and Databricks notebook became famous. Databricks is a company which provides Databricks notebook, where you can write Python, and probably you can also build Spark application, build data pipelines by using Spark. By using Spark, you can write. They give an opportunity for you to work, to write the code in Python or Scala, or probably they don't provide in Java, obviously. So So these notebooks kind of environment, you know, this is an interactive, we call these as interactive notebooks. If it's, I didn't include that, interactive notebooks these are. So because it's called interactive because each cell yields the output immediately as soon as you execute that. You don't need to even execute. If you just hit control enter or probably shift enter, it executes that particular cell. I'll tell you what exactly the cell means, or maybe command means. I mean, if you have not worked with any notebook, interactive notebook, but if you are a kind of a person who have already experienced with Jupyter notebook, then you know what I mean and what I'm actually saying, you know. So yeah, we'll talk about that. So that, I mean, this is the reason why we have chosen Databricks, and also in the production, and also in the what do you say that the, you know, the current trend which is going on, all the companies who are using Spark are incorporating and building data pipelines by using Databricks or maybe Zipline. Zipline you know, comes well with AWS as well, but Databricks was an individual standalone company who were providing this environment with clusters. But Databricks became so good, they you know, it became so famous, and their work was loved by many you know, Spark developers and data engineers, that Azure told that hey, you know what, your UI and everything looks good, we'll pay you money, can you please integrate the Databricks in our portal as well? Which is why in Azure portal you can see Azure Databricks. So it's like they kind of pay some, you know, some kind of licensing part, you know, the Microsoft pays some sort of money, or maybe, you know, licensing tender probably they'll provide for Databricks company, and they say that uh, we will use your everything, that's how you have developed all those cells, but the only thing is we'll be providing we'll be connecting to Azure cluster. The same thing goes with Databricks alone. If you want to work with only Databricks also provides clusters. You know, cluster in the sense that it's nothing but a group of machines, you know, connected to each other via network, strong network, right? um, so that's why Databricks is very famous and also used. Okay, and these are some basic things which I really wanted you to know. And let's, I mean, I'll tell you about why what's the difference between on-prem and cloud. uh, let's say that there is an XYZ company, let's say that it's storing some financial, I mean, it's a financial company and it stores some financial related data, something like, you know, SSN number, or maybe what sort of insurance policies is I mean, what is the policy number, what is the policy amount is being paid by the customer, or whatever. These kind of things are very confidential information, and companies which, I mean, the financial companies do not wish to store such kind of information in cloud, because they still don't trust cloud. I mean, see, there are how see, these insurance companies comes under BFSI sector, which means BFSI in the sense banking, financial sector, and I mean services and insurance. So, and all the other you know, pillars, or maybe I can say sectors like retail, pharma, and whatever, all those, hospitality, media, all these things, they have moved to cloud because it's fast, and they don't, I mean, they don't bother, I mean, they do bother about the data, but the thing is they're not so confidential like the financial data. But BFSIs, they don't, I mean, BFSI sector, whatever, whichever companies come under BFSI sector, they don't really, you know, so easily trust the cloud, because they think that it's not in their hands when the data is in cloud, and there's always a chance for a breach if security and their data gets hacked or might get leaked or something like that. So that is the reason, but never mind. So I'll tell you what happens in on-prem. When this company wants to store some data, they will contact some, I mean, some companies like Hortonworks or Cloudera or Mappa, or some, I mean, these are the companies which provide on-premises servers or cluster. They come and build, so they're gonna pay some money. I mean, they're gonna call this company, XYZ company calls maybe Hortonworks, Cloudera, or Mappa, and they're gonna tell that, hey, you know what, I want a cluster, can you please come and build the cluster in like in our vicinity, or maybe in our organization. So they're gonna bring, they'll I mean, Hortonworks begins to buy all the, you know, installation, whatever servers, and they're gonna hire some people to, for I mean, engineers to build, network engineers to come to the premises of XYZ company, and you know, they'll set up their servers and the cluster in the premises of the company. They will build in where the company is located at. And I mean, obviously servers get heated up, so they'll be providing an AC room for cooling those things. So this complete structure which is happening, which I just told you, is called on premises. Means the server and the cluster is in the premises of the company. That is why it is called on premises. Okay. And but the thing is, you need to have an admin, you need to hire a resource to take care of this cluster when cluster goes down, or maybe some machine goes down, or you need to restart for maintenance, you know, this kind of thing. You need to hire a separate team for this, so you're gonna pay for that. So all these things is headache. And if there is any new version, the admin teams need to work on weekends, week offs. There will be some downtime whenever there is an upgrade, and there is a separate project called an upgrade whenever any version gets released. So this is a pain in the ass. So that's why nowadays all these things are not I mean, you know, kind of preferred nowadays. So directly, let's say that the here in another case, I'll give you an example. In another case, there's a company, I mean Adobe. So this is let's say that these people think that they don't want on premises. Let's say that I don't need an admin, okay, and I don't need to take care of, you know, the versions, and I don't need to hire a separate team for any downtime or anything. So if this is the requirement of the company, then the companies like Azure, I mean the cloud providers like Microsoft provides Azure, and Amazon provides AWS, and Google provides Google Cloud Platform. So these companies provide the infrastructure, the cloud infrastructure, where everything is taken care by the company itself. If there is any new version, they're going to take care of the migrating part, and you don't need to take care of, you know, versioning. They'll just release it in the next version. As soon as they see that, you can actually use their UI to choose which version you want to use. So these kind of things can be done in cloud, and it's paid only as you go, which means that you pay only for the amount you have used. Let's say that there is a storage, if you have used only 100 terabytes, then only 100 terabytes of data you will, I mean, you the charges are how much, the according to that used 100 TB, or maybe 500 the petabytes or terabytes you have used. Only for that much you are going to pay. That is what you means pay as you go, and as much as you use, you start to pay that much. But if it's on premises, you have to pay upfront. Let's say that your data comes maybe 1 GB per day, so it's going to be 30 GB per month, then 360 GB, approximately 360 GB in 1 year. So if you take let's say that 512 terabytes or maybe 1 petabyte, then you need to pay upfront for the amount of 1 petabyte of server storage for like in the on premises, which is very expensive. So this is the difference between on premises and cloud. So that is why we'll be using cloud. So all these things, all this information which I just told you is because what we are doing, we're gonna deal with cloud. I'm gonna showcase you this in cloud, because Databricks, the community version of the Databricks is in cloud, and I'm going to use Databricks notebook, and I'm going to use PySpark, and I'm going to use JSON data. Now why JSON data? We left that, we spoke about why we're using PySpark and all the other things, cloud and all, but I didn't tell you that what's about JSON. But first, let's see how the data looks like. I'm gonna go here, I'm just gonna double click this. Let's see how the data looks like. This is how the data looks like, right? The reason why we are using I'm gonna show you the whole agenda of showing working with JSON file is because you cannot always expect the data is coming from the structured format, that is in a tabular format. If you're working with any product based company which is having an application of Android, or if you want to work with some company which is of sensors which are generating web logs or maybe streaming data, these data are actually which comes in a no structured format. That means there won't be any structure for it. There won't be a definite structure for it, or if I have to say that, because there won't be a specific certain number of columns which will be coming every single time. The columns might increase, the columns might decrease, so that is why it's no structure. So you'll be dealing with NoSQL. When we say with NoSQL, when we talk about NoSQL, which means that the data is, when we say that it's NoSQL, that means the data is unstructured, right? When it is unstructured, which means the data will be most probably in the form of keys and values, right? That is key value pair is what we call. And what is key value pair? The key value pair is nothing but in the Python, if you call, it's dictionary, and the format of the JSON is, the data will be, if the data is in keys and values, if the data is stored like this, then it's definitely a JSON file, which is an extension of JSON. So this is a key, this is a value, and this is a key, and this is an array of values, right? So, but what we are going to deal with it is, if data comes in this format, how are you going to deal with it? This is the agenda. How you are going to refine this data if you are getting that. And JSON looks fine if there is only keys and values, but there is a nested one. If you see here, this is a nested, there is another data sets has one value, that is this, there is another value called order details, and there is another called product IDs, things which is all nested. Doesn't seem, you cannot understand how it looks like because the structure is weird, but once we import it, I'm going to show you how exactly it looks like. So the data is nested here. This is a nested JSON file, means the data is very much has an hierarchy. So that is the reason I'm going to show you how it is. So we'll be working with JSON because like I said, most of the time when you're dealing with in the project, sometimes, most of the times you'll be working with NoSQL structure, maybe MongoDB. Let's say that, okay, if you have an Android application, some company that is a retail company, or maybe like Walmart, Walmart has, let's say that Walmart has an application, an Android application, and that is generating orders data, and the data is collected by data ingestion team. Okay, and when the data is collected by the data ingestion team, the collecting team collects and stores in JSON format, or maybe HBase NoSQL. This is a NoSQL database, so which means that the data, when you read, the data will be in the JSON format because it is in key value pair, right? So if this is the case, then you will be dealing with JSON file, obviously, not a structured, right? So I'm just giving an example of HBase. It can be MongoDB, right? It can be MongoDB. So all these are NoSQL. It can be DynamoDB, Cassandra, whatever thing, as long as you know cap theorem. I don't want to go too deep. There is a reason why you should choose HBase. There is a separate concept called cap theorem that depends on the project, whether your project, I don't want to, never mind. The more I say, it will be more confusing. So let's just stick to the point. Great. So that's how it is. So let's say that now I'm going to show you an example. First, the relational database. Let's say that how this is how the JSON file looks like. But first, if you are dealing with a relational data, the data looks in something like tabular format, that is like this, that is having a first name, last name, and age. The reason why I'm going to explain this particular concept, and you need to pay attention to this, because why people are using, they could have just used different, even if it's in JSON, or maybe it's still a data. They could still use it in tabular format, right? Why did they read? Why companies started to use JSON files or any related to file format, the data in file system, and not something related to a tabular format? I'm going to tell you that. See, relational data stored in tabular structure. That's like this. It can be any SQL DB, like SQL Server, MySQL, PostgreSQL, Oracle DB, IBM DB2. No, you just name it. Everything, it will be in a tabular format. And let's say that there is first name, last name, and age. John Carter is first row. this is a column. This is a column name. This is one row. First name, last name, and age are the column names. This is one row where John Carter, age 35, Stephanie Cruz, that is 23. Stephanie Cruz, whatever. So this is two rows. Okay. Let me tell you the key terminologies when you're using with SQL type of data. This is a table. The table name is employee table. These are column names. These are rows. Got it? Now, if you're dealing with a NoSQL data, you're going to use the term very slightly different. This is employee collection. These are fields, or you can say keys. This is a value. This is the keys. This is a value. This whole thing, this part, which we call it as a record or a row, is called a document. So employee collection, first name is a field. This is the whole thing, this which comes under the curly braces, that which we call in the table, like in the tabular format, which we call as one row, is called as a document in the NoSQL. These terminologies are very important when you're dealing with, in the interviews. If you're gonna tell that you are dealing with NoSQL data, and if you directly go and tell that I was dealing with employee table, they're gonna know that you did some course and you have come to the interview just for the sake of faking your resume. Okay, because the data engineers use the term very that is related how the data is, because if you're dealing with NoSQL, then you're going to use employee collection. It's not employee table, right? So this is how the data, the exact data, how it looks in the table, and this is a replica which how it looks in the JSON. I'm just gonna zoom out a little bit so that both these curly braces. So inside one curly braces, employee collection, this is one document, this is another document, which is just for the sake of conversation, for me to teach you guys, I'm going to use the old terminology, the SQL type of terminologies. Okay, so this is a table, employee table, this is a columns, and this is one row, this is second row, right? Now they could have used tabular structure. Why JSON? Why key value pair? Why dictionary type? I'm going to tell you that. Assume there is a record row, maybe I can say that, something like this. Some good name, Mike Ross, because I love suits. Mike Ross, and there's nothing. If you do not put anything, that's called null. Now age is an integer. Let's say that last name is a variable character, and first name is also variable character. Now how does this row look in JSON file? I'm going to show you how it looks. Is it's going to be like this. It's going to be Mike, it's going to be Ross, there won't be age. Remove this. This is how the JSON looks like. This is how the JSON file will look like if the data looks like this. If the structure table looks like this, the JSON file will look like this. Why? You would think like, okay, what's the big difference? So what? I'm going to tell you why. So what? Look at this. How do you write the create statement for the tabular structure, or maybe SQL? Create table name, that is in our case employee, and you're gonna write something like this. first name varchar, let's say that we have some 25. I'm just gonna copy that, and I'm gonna put last name. Okay, and then I'm gonna put age int. Is this how you're gonna create? Okay, this isn't dummy thing, but okay, just leave about the primary key, not null, constraint, all these things. Just for example's sake, create table something like this. Just ignore all this. This is a Word document, so I'm not able to create table, whatever this. Okay, this is how it looks like, right? What is, if do you really think null doesn't store a memory? What's the memory for null? Okay, we don't know, but according to SQL manner, null takes the width of the field of fixed column. So if null was there in varchar, if null is there in varchar, it doesn't take any memory, but age is a fixed field, which means age by definitely it is integer, and integer has a fixed memory, and the fixed memory of int is 8 bytes. So the value of null, so null which occurs in int field will take 8 bytes. Got it? That is the agenda, that is the thing, that is the speciality of the null. And this is an issue. Why? You'll be dealing with billions of records, and what do you think will happen if you see that there is a lot of data that is recorded and many people did not reveal their age, and there is a billion record or a million record. There's a million record which is having a null as a record, and what's going to be? How much is the memory location? How much memory is consumed, but it's not used much? 1 lakh, 10 lakh, 1 million. This is 1 million multiplied by 8. Really? This is the bytes, and we divide by 24. 7812 GB of data is stored as null. Huge waste of memory, isn't it? Huge waste of memory. But if JSON doesn't care, JSON, if it's null, it's not gonna bring that. It's not gonna store. And don't you think this is saving memory? Even this tiny thing also matters when you're dealing with a million records, because storage is very important. Storage are expensive, SSDs are expensive, HDDs are maybe cheaper. Hard disk drive is cheaper a little bit. They are called disks, and SSD is solid state drive that is really fast, so they're expensive. So memories are expensive even for companies to pay, right? So that is why they don't want to pay much. So if you really think, if this was on premises, this much of data was simply lying, nulls will be lying there completely wasted, and they have to pay for it, right? And also if this was in cloud, unnecessarily for 780 something 780 and odd GB, they are paying money, because that is pay as you go. If you remember, the cloud is pay as you go, right? And if you think if you are storing null values in cloud, wherever they are located, don't you think that it's really going to waste their money unnecessarily? Yes, that is the reason. So this is very important. That is the reason why NoSQL became famous, right? Good. Now all these basics are done. Now we can actually go in structure and go inside, and we'll discuss about what we are going to do. We'll be using Databricks Community Edition, and just gonna walk you through just 2 minutes how things are. This is a UI. Just Google or YouTube how you'll get free Community Edition, how to register for it. And there is a tons of video, you can just go through it, and I just want to cruise into the thing which I want to convey here. So this is called a blade. If you remember, okay, like I said, the terminologies are really important. Even in Azure platform, this particular pop-up which you can see in the left side is called blade. And in also I use the same thing in the Databricks as well, because this also comes like a blade. So this is a blade. We have create. If you create, you can create a notebook, you can create a table, you can create a cluster. And this is a workspace. If you register for using email, so if you go to users, there is my email address. This is just dummy email which I created. So inside that email, if you're registered, you can create folders. You can click on this tiny arrow which you can see here, right? You can see this tiny arrow. So you can create a notebook inside this particular thing, or you can create a folder or a library, or if you want to do something experiment, which I really have no idea what that means. So you can clone something, you can import, which if you have a Python file which you have written in Python, you can import that. And if you want to export this particular notebook, then you can export that. This whole folders get zipped and gets exported, something like that. So once you created that folder, let's say that it's in documentation, and we'll be working with JSON. That's what we are located here. So click on this folder. There is our notebook. So how did I create the notebook? I just created this. I click this and then create, and then notebook. Then you can name something over here, and then you can choose which language it is. So you can see here Python, Scala, SQL, and R. Don't think that SQL means you're gonna write SQL queries on the Spark, which is you can write Spark application, but this is higher level construct. So you can use SQL also if you have created a table or data frame, right? So that's what I mean. And you can create you can attach it to a cluster. And I'm going to tell you, we're going to go to the cluster, right? Wait, this is recently whichever I had opened recent notebooks that is listed here. That's nothing to know about, just a search workspace, because if you are in production, there are many people working on same thing in the same project, or maybe different project with a different names or teams. So if that is the case, you can search your workspace, right? If mine is a user, so I can just click on users, because I can search, because I know mine there is only two workspace, that is this is back, this is back, and you can see here there's two workspaces. Coming to data, we'll come to the data later. First we'll go to compute. If you go to compute, you can create a cluster. Now community edition allows you to create one cluster, okay, but that is just one machine, okay. This is for free, as much as you can use it, there's no harm. And if you are keeping this cluster idle for 2 hours, post 2 hours it's going to get terminated. That is it, it gets terminated. This green thing which you see gets grayed out, so that means you cannot use it, it's not active. So you see, like I told you, it's going to create only one cluster because it's free edition. Let's say that I'm going to create new cluster, and you see you cannot create that. What does it say? It says that you have reached maximum number of active clusters. Please terminate an existing cluster or upgrade to larger plan. Now if you are upgrading, then definitely you need to pay for it. If you see, there is only one driver, which no worker. Driver itself acts as a driver and also worker, which means that this is a name node and also worker, something like that. So you can see this is a 15.3 GB memory and 2 cores. This is a CPU, this is a RAM, this is a CPU, this is something Databricks utility, something Databricks unit. It's something processing, inbuilt processing capability. So you can create just one, which I have already created cluster for this session. So it's called DataSpark cluster. Just named it on my whatever. I felt really cool. So yeah, it's running. This is one node cluster because they have given. How much we can expect? They're already providing it for free for us to work. So, and runtime is 9.1. This is a DBR. That means Databricks runtime, which means that it includes 3.1.2 Spark version with Scala 2.1.2. You don't need to, it's not that if there is Scala we have to use Scala. You can use Python as well, not to worry. So driver is community edition optimized, and worker is also community optimized. Creator is you, that is if you're registered with your email, that's the name you're gonna get. And here are the actions. You can terminate, you can refresh, you can restart, you can clone this particular cluster, but cloning will not help because already we have this cluster. So there are two types of clusters. If you see here, this all purpose cluster and this is job cluster, which I'm not going to explain much deep because this is not in the agenda. okay, but we'll be using all purpose cluster, okay. And there is something called jobs, but in community edition you will not be able to create jobs. Job is something that, you know, you cannot log into your laptop every single time and open your notebook and then click run all, isn't it, for you to execute this code. So you'll create a job which automatically schedules this particular thing. So this you can create jobs for this, for I mean you can create a job, and you can give a job name, and you can point that particular thing to, let's say that you create a job and you point your job for this particular notebook, that is maybe this link or something like that, and that job can actually execute this particular notebook when you are offline, which means this will be in the cloud. So this will be scheduled in the cloud. So you can schedule that. Let's say that I want to execute in, let's say that it's 4 p.m. 3:50 4 p.m. IST. If you want to execute that, if you set it, it's going to execute at 4 p.m. IST, Indian Standard Time, whatever. You can choose the time zone as well. Okay, now coming back to our, okay, so that's when I said, so when you create a job, it's going to use the job cluster, right? There's no job cluster now, but you cannot create the job. You cannot create a job, so that means you cannot create a job cluster. So there are two types of cluster. There is all purpose and job cluster. That's it. That's all I want to say for now, because if I start explaining what is job cluster and what is all purpose cluster, it's gonna take a while, right? So I'm just gonna, the whole thing till now, whichever we spend a lot of time on, you know, explaining of the basics, because I want you to understand. Because I explained so much background and the basics before all of this, because if somebody is watching my video with complete no background, they should at least understand some part of it, right? So that's why. So you can create this heading. This is the name of the notebook, is working with JSON file and PySpark. If you're wondering how did I write this kind of thing, if you just double click it, so this particular thing is called cell. What you see rectangle thing which is here, like that is here, this thing is called a cell. This is called another cell, or you can say command or cell, whatever it looks like to you. These are cells which I'm drawing in the blue lines, okay? So you can do something like %MD, that means mark down. I'll just zoom in a little so that it looks pretty good for you guys, a little bit bigger. Okay, this is a markdown. And also towards the right side, if you see, how do I know it's a markdown? If you see here towards the right corner, there is something markdown. Markdown in the sense you can actually write HTML kind of code, and that looks, I mean, it's not such a, what do you say that, it's not really a kind of a code or something. If you want some information to be provided by the developer, if a developer develops this notebook, and let's say that he moves to the new organization and he writes some direct code and doesn't inform anything to the new developer, and any new resource comes to the organization, and when he starts to work on this notebook or perform any optimizations on this notebook, he doesn't know what this means. So that is the reason you can write something like markdown, right? And then you can inform this. So what I've informed is the reason we are working with JSON, because most of the applications use NoSQL. Yeah, I have explained you all this, because if you're dealing with NoSQL data, then the data comes in a key value pair, which is nothing but a dictionary format, and which is nothing but again JSON file, and the key value is nothing but again a dictionary type. So yeah, this is okay. Cell number 4 to 19 is pure work of fixing schema. That's what we are going to do. That's the whole agenda. We're going to fix that. So we're going to import it. Let me tell you one more thing. To execute this, you can obviously go and click here run cell, but the shortcut is you can use shift and enter. I'm going to type that first. Shift plus enter key in your keyboard. That's what that's going to do is that is going to, let's, if you can see there is a blue color highlight on that cell towards the left side, right? Which means it the cursor or the execution will take place on this cell if you execute. So if you're using shift enter, this particular cell will get executed and the selection will go to the next cell. Okay, it's going to execute this, and the next pointer will be at this location. Okay, if you use control plus enter, if you use control plus enter, it's going to, the blue color selection which is towards here, this particular part, this thing, it's going to stay at the same cell, right? It's going to stay at the same cell like this. It will execute this command, that is command 2. It's going to execute this and it's going to stay there itself. This is small information. I mean, it might come in handy to you when you're working, right? Because you will not see me doing this particular thing in the screen. That's why. Okay, I'm going to execute this. I'm going to use shift enter. I'm going to import that, right? And it is, the blue color thing is not, it's showing something related to black or maybe brown. I'm not sure, maybe I'm colorblind, but I'm going to execute that anyway. Okay, this doesn't, if you execute this is not going to do anything. It's not going to execute, it's just going to retain that. I'm going to shift enter. It's going to show that regular data engineering processing for loading the data. Now we did not discuss about the data. The data is, I have loaded already the data. You have seen, right? This is the data.json. I have loaded that data.json in the DB. This is a Databricks data folder, where it's going to create the tables. If I go to hit create table, and if you can store the data in, the data can be stored in files, something called file store / table / and that will be there in the DBFS. If you go to file store, if you go to tables, I already have the data here. Let me just delete this. I had put the data multiple times, so it's data 1, data 2 and whatever. So let me first delete this. You from the UI you cannot delete this, maybe for that. Let me, okay, can you, if you hover towards the center of the cell, there is something called plus. If you click that, it's going to create a new cell. Don't worry about this. This is, I'm not gonna cover this. I'm just gonna remove the files. Is it file store? Yes is capital. Yes, I know that. I'm gonna delete this. Is it tables or tables? Okay, table. Okay, it should return true or false. If it is true, it has deleted. If it is false, if it returns false, that means it did not delete it. True, that means if you go back here, if I click there is data1.json. If I click tables, and if I again click tables, data 1 is deleted. Now the same thing I'll go and do for data 2. Control enter, again true, and I'm gonna delete data.json as well to show you how to load the data. Right, so if I go back and if I click tables and if I click again tables, there is absolutely no data.json. I'm just gonna delete this cell because we don't want that. You can just Google what is DB Databricks utils functionalities commands. You can get that. I'll upload the file. I'll upload it. I'll drop the files here directly. So let me just, okay, it directly opened this path for me. Data.json, open. You should get this green color tick mark, which means it has loaded. So if you go to DBFS now, you can see file store, you can see tables, then you can see data.json. Right, this is the path where it is, and I'm going to load this data right first. Okay, we have executed that. If you see that the command took 0.04 seconds, executed by my email address. Today is the April 4th 2022, and it's 3:54 Indian Standard Time. On which cluster? Dataspark, which we have created. Right, let's create this. Let's execute this particular command. I have written all this code because it takes time for me to again write and explain, so it's better that I've written it in like beforehand so that I can explain you in an easier way. Right, so I think there's a network connectivity issue, which is why it is showing disconnecting. I think there is some issue with my network, but meanwhile I'll just connect to some other connect internet probably, so that it will be, so that I'll execute that. iPhone connect. I'll connect to my mobile hotspot so that I'll get the data. I don't want to delay things here, so great. So this I'll execute this particular thing again. It's running a Spark job. Took 4 seconds, so the data has been loaded. So now let's check the schema of it. Now here is going to how you're going to see that. See, this is how the schema looks like. Completely, it is a JSON which is in the root. There is a something array of type. There's an array type because that's how it looked like. There's a customer ID field. There is order date field, and again order details is an array which is internally contains multiple fields like product ID, quantity, sequence, and total price. Total price is again internally nested, which is gross, net, and tax. This is nested JSON file, and this is how it looks like, right? Great. So we are going to bring this particular data. I mean, this looks pretty much fine because schema should look like this. Okay, this is fine, but if you see the data how it looks like, you're gonna go mad seeing that how do you work with this. I'm gonna show you that how it looks like, how the data frame looks like. Orders data frame, we loaded this particular thing, we loaded into orders data frame. So let's see how the orders data frame looks like. It's still executing. This is how it looks like. So there are two arrays, that is array of 0, that is this record, array of 1, that is have this record. So there are two things. Then this is how it looks like. There's only two tables, two fields, or I can say two columns. Now you cannot work with this. This is a nested thing. See, if you click on this particular small arrow, and if you click on small arrow, keeps getting nested within the nested. But we need, even though this is a NoSQL, to work with, to derive some insights, you definitely need to look or to have it in the tabular format, something which is structured. We need to bring from no structured or unstructured data to a structured format. This is what we are doing. That is what our agenda is. From JSON file, we're going to work on the JSON file which is having a nested JSON file data by using PySpark. So what we're going to do is, this is how it looks like. Do remember this. There is array of 2 elements. This is very important. I'm going to tell you why. Now, to bring it to a proper format, we need to explode. What is an explode? Explode, if you go to the PySpark documentation, Spark documentation, explode means it returns the new row for each element in the given array or a map. For each element, new row means what? Array, there are 2 arrays, 2 new rows. Ring a bell? Yes, that's what it means. Means if I explode on datasets field, I should get 2 rows. 2 rows, isn't it? That's what it means, right? Let's try to do it. I'm going to use the orders df, that is the same data frame. I'm going to use explode function on orders df dot dataset, because dataset is the, where is that? Yeah, this is the one. Dataset is the array. So you're going to explode on an array, that is dataset, because this is directly connected to root, right? But we don't want this field should be connected to the root. That is the agenda here. That is called processing the right. See, customer ID should be connected to root. It is nested one within the other. We cannot do root dot datasets dot element dot. No, we cannot do this. This is wrong, and even that is wrong syntax as well. Got it? So we're gonna do explode on orders df dot dataset, and we're gonna rename that thing as orders, right? So basically, instead of showing here datasets, directly these customers should directly get connected to orders, and orders will be connected to root. It will come under root, the hierarchy. So that is how it should look like. Will it look like that? Let's see about that. I executed that. That is control and enter. You can see here that's the reason why the blue color is here. Now let me do shift enter. So shift enter. Let's see the print schema. So here, see the difference. Here the difference was customer ID was under element of under datasets under root. Now customer ID is under orders. Now order is under root, which is okay, better, that is fine, which is progressing. But okay, let's see the data, because we exploded. What was the exploded thing? The definition was returns the new row for each element in a given array. And what was the how many records are there in the array? There are 2, that is 0 and 1, right? There are 2. Did we have 2 rows? Let's check about that. Shift enter. See, great, we did have that. So we did explode it, isn't it? That's good. Now, but again, if you see, there is nested things. This order details contains two records again, and there is another customer ID where order details contains 2 records. So if one row is having 2 again sub array elements, and if second row contains 2 array elements, if we explode on each row on based on order details, how many rows do you think it's going to return? 4, isn't it? Well, that's what we think, but let's see about that. Okay, what we are doing here is I'm going to make all of this order, customer ID, order date, everything come under directly the root, because that is the whole agenda is. We do not want every single time to work with orders dot customer ID, orders dot, we don't want to use this dot operator, maybe, you know. That's the reason what I'm doing is I'm just gonna placing this orders df dot select orders dot star in back to parse order df. Execute that, and then again execute this print schema, and you're gonna see excuse me, directly customers ID and everything is under root. But still our problem is still there, that is order details is still having nested data, and again total price is having again nested data. We'll deal with this, we're gonna deal with that, but first we'll see how the data looks like, because we split that because since we do not have orders directly here, all the fields came under root. Now it started to make sense and it's starting to split into different fields, but still we still have two records. We at least we got order details that is having 2 elements here, and order details of another customer is two elements. So we still need to explode on this array elements. So we're gonna explode on order details field, that is column. Okay, so that's what we are doing. We are gonna do, we're gonna keep this data, I mean fields, but we're going to explode order details, and we're going to rename that column as again as order details. So I'm going to execute that, and then I'm going to check the print schema just to showcase you guys how it looks like. So if you see, order details has exploded. This is more or less, it looks kind of pretty much same, but the thing is, if you see the data, now you have 4 records like how we had expected. If you have order ID, okay, for some reason shipment details comes towards left side, but our data is in this format. Product ID is 001, product ID is 002. This is another customer who has ordered product ID 001 and product ID 004. Okay, but if you see shipment details, that also contains sort of, you know, elements like this. So we should split this time. We are not going to explode. What we want from this shipment details contain some address kind of information, that is shipment related information. We want city to be in one column, we want country to be in one column, we want postal code, that is zip, in one column, and state in one column and street in one column. I think the similar thing also applies to order details, because we need product ID in one column, quantity in one column, sequence in one column, and we're gonna see how we'll deal with total price, because this is nested again. This is again an array. We probably need to again explode on total price, but let's do that later. But at least for now we need to split this each field that is inside shipment details in each column. To do that, this is called flattening. And there's no special thing to flatten. You can just use with column functionality. So you're gonna, from this data frame contains all these fields, right? Because that is new parse orders df, that is the same new parse orders df, and I'm gonna use with column, and I'm going to, this with column is, if it finds the match for this particular column and you're gonna use this first parameter, it's going to rename that. You can use with column renamed function also. There is something called renamed, but with column is kind of a superposition of the method, the function. If you give two parameters, the second parameter, if it finds a match, then if it's going to rename to this particular name. So I'm going to have with column that is going to split this particular shipment details dot city. I'm going to name it just as city, and shipment details of country, I'm going to rename it as country, and the same goes for the rest of the things. And I'm going to drop shipment details, because it's going to create new fields, because anyways individual fields I'm going to get split it out, but then this shipment details is going to retain within this data frame, which I do not want. I want to drop this field, because anyways I'm going to split this field into a new thing, so I don't want duplicated data. So that's why I'm dropping shipment details. Okay, so let's see how it looks like. First I'm gonna execute this, and now let's see how the data looks like. So basically shipment details data should be split into different columns. Okay, now again order details came towards left side for some reason, I don't know why, but good thing is we split the shipment details into this, that is city, country, zip, state, street. If you see, I did not rename postal code as postal code, I kept that as zip for my reference. I just want to let you guys know that you can name anything here, right? So great. So this, I think we should do the same thing for order details as well. So what we're gonna do is we do the same thing, just get that same final df. This is not final, so we are developers, we're gonna name this anyways, anything. So final df dot with column, again product id I want, and I want to rename that as from order details dot product id, because that's how you're going to access this particular key, order details dot product id, and you're going to rename it as product id. The same thing, same principle like how we did in for shipment details. The same thing we are going to do for order details, but only this time again we are dropping order details, because we do not want this particular column which contains nested, because this particular code is anyways going to split individual columns, and I don't want this column to retain again to have a duplicated data. Let's run this command. Let's see how the data looks like also in the new final data frame. Great. So again shipment details related data columns came this side. I'm going to scroll towards right side, which is our this information, product id, quality, sequence. Great, nice, but we still have total price. I think we need to flatten this as well. We need to flatten this. We need to have three columns, which is gross, net, and tax. Again we can flatten this. Again same thing, we're gonna flatten this. Again net price total price dot net as net price, total price dot tax as tax, and total price dot gross as gross price. And again I'm gonna drop total price, that is total price is nested. It is nested, so I don't want this particular field. I want to drop that field by retaining after splitting this column. So I'm gonna run this, and let's see how it looks like our final data frame. Great, looks pretty fine. Let's see about that gross thing. Yes, it has split into different fields. Now this is a tabular format. Now on this we could do SQL type of queries, we could do create a new temporary table. We can derive insights for the future people who whichever team wants to derive insights. So this is sort of refining the data. This is sort of looks like, you know, working with a JSON file. And finally, let's see how the schema looks like. It should see everything under one particular thing. See, we finally brought to this particular schema from where we started. We started from nested, which looks like this, and we brought it to this. So yeah, this is how you work with JSON file. Something, you know, a simple concept, but don't worry, in the production this will be very complex. You know, this is just couple of records, couple of columns. You'll be working with 1,000 fields, like, you know, there'll be maybe 50, 100 nested things, which is nested like this. So yeah, it's a good experience, but this is just a small example. I hope you liked the session. If you have any doubts, do let me know in the, you know, you can ask me, and you can join our Telegram private channel, where, it's a private channel. It's only for, for dedicated people who want to work like this, who want to attend session, and we discuss ideas and technologies. So hope you liked it. So do let me know. If you have any questions, I'll be happy to help. Stay safe. Thank you so much.